Hello everyone, welcome to our channel. In this video, we are going to solve a problem which came in the year 2017 in JAM Biotechnology paper. Here the question is, a body X of mass capital M moving with velocity small v hits a stationary body capital Y of mass small m. If capital M is much greater than small m and X moves with the velocity v prime, then the velocity of capital Y, that is Y, after an elastic collision is option A twice small v, option B small v plus v prime, option C v minus v prime, option D twice v prime. Okay, so let us solve this problem. So in this problem, problems like this, you have to remember that in elastic collision, two quantities remain constant, okay, or two quantities remain conserved. Okay, one is linear momentum and another is kinetic energy. Okay, the total linear momentum is conserved and total kinetic energy is conserved. Okay, now let's see the problem. First of all, this is our body X having mass capital M, and this is moving with velocity small v. There is another body which is stationary. Stationary means it is at rest, that is it is not moving, that is its velocity is 0. Okay, so this is our body Y whose mass is small m, okay, and this is at rest, it is not moving. Now what happens is, this X hits Y and they collide here, X and Y, okay, they collide, and the collision is elastic collision. Okay, the collision is elastic collision. Okay, and after collision X moves with velocity v prime. Okay, X moves with velocity v prime, and we need to find the velocity of Y. Okay, we need to find the velocity of Y. Suppose the velocity of Y is Vy. Okay, so we need to find the velocity of Y, that is we need to find Vy. Now, as I have said that in elastic collision, in case of elastic collision, two quantities remain conserved. One is linear momentum and another is kinetic energy. Okay, so let us write down what are the linear momentums of X and Y before and after collision. Okay, so the linear momentum of X, okay, of X is, linear momentum of X is mass times velocity, right? That means m times capital M times small v, right? that of this y is small m times 0, because it is stationary body, it is a stationary body, that means it is at rest, that is its velocity 0. So m times 0. Now after collision, the momentum of x is its mass, that is capital M times v prime, its velocity, and that of y is small m times Vy. Okay. So, what is meant by conservation of linear momentum is the total linear momentum before collision, that is mv plus capital mv plus small m times 0 is equal capital M v prime plus small m times Vy. That is the linear momentum, total linear momentum before collision is equal to total linear momentum after collision. Okay. So, if we solve this, we get capital MV equal capital M V prime plus small m Vy, right? So, from this we get Vy, small Vy equal capital M times small v minus v prime divided by small m, right? Now, let us write down, let us find what are the kinetic energy of x and y before and after collision. Okay. So, kinetic energy, let us write it in as Ke. So, kinetic energy of x before collision is half mv square, right? Formula for kinetic energy is half mv square. So, half capital M small v square plus, sorry, not plus, first of all just write down the kinetic energies, okay? Then we would add them and see what it gives us. So, half mv square for y, it is half small m times 0 square, right? For x, for this x after collision, it is half capital M v prime square, and of y after collision half small m times Vy square. Okay. So, as I said that kinetic energy is the quantity which is again conserved like linear momentum. Okay. So, for that the total kinetic energy of x and y before collision, that is half mv square plus half m times 0 square, is equal total kinetic energy after collision, that is half capital M v prime square plus half small m Vy square. Okay, and solving this we get half capital M v square equal half capital M v prime square plus half small m Vy square. Okay, so let's cancel the halves from both sides and we get Vy square equal v square minus v prime square times capital M by small m. Okay. So from these two equations, that is Vy equal m times small v minus v prime divided by small m, and Vy square equal v square minus v prime square times capital M by small m, we get, if we just divide these two equations, we get Vy square equal v square minus v prime square divided by capital M by small m by v minus v prime divided by capital M by small m. Right? This is, if we divide, so let us just mark this equation as number 1 and this equation as number 2. So we are dividing 2 by 1. Okay, we are dividing equation 2 by 1. Okay, and that gives us this. So if we cancel this with this, we get Vy equal v square minus v prime square, right? That means v minus v prime times v plus v prime, right? And here this m by small m, capital M by small m and capital M by small m cancels out, divided by small v minus v prime. So these two cancels out and we are left with v plus v prime. Okay, so Vy is equal v plus v prime. So let us go back to the question. Here, see, the option B is our correct answer, that is v plus v prime. This is our Vy, that is the velocity of y after elastic collision. Okay, so we could successfully solve this problem. If you have any doubt regarding this solution, you can tell me in the comment section. If you like this video, please click on the like button, share this video with your friends and don't forget to subscribe our channel. Ta-ta!